types. One is troponin C, one is troponin I, another one is the troponin T. Now, the calcium binds to troponin. That troponin is called as a troponin C. C indicates calcium. Now, the troponin can binds to the tropomyosin. This is binds to the tropomyosin, that is called as a troponin T. Suppose this is actin, this having a active site. When a troponin can mask the active site, that is called as a troponin I. I indicates inhibitor. Suppose you have to think this is actin, this part is called as a active site. Now this is troponin. This troponin can mask the active site. Can mask the active site means that is what action? Inhibitory action. That type of troponin is called as a troponin I. Okay. Now first what will happen? The calcium is binds to troponin. Now the troponin is called as a troponin C. After what will happen? Now this is active site, this is troponin I. The troponin C touches the troponin I. At that time troponin I change the position. When it is changed the position, here what will happen? Active site is exposed. Before it is covered with the troponin I. Now what will happen? When the mask is changes or position is changes. When the position is changes, active site is exposed. Now here, see, when the active site is exposed, now this one you have to think the active site. Active site is exposed. This is the exact location. This is A band. The globular heads. The globular head is towards to I band. Here also a globular head towards to I band. This is actin. This is actin. Now what will happen? On globular head, I can take this part into here. Here on globular head, I already said they having an enzyme. That enzyme is called as a ATPase enzyme. This ATPase enzyme can release the ATP. Now this ATP is hydrolyzed. It is converted to ADP plus pi, inorganic phosphate, adenosine diphosphate. By the using of this adenosine diphosphate and inorganic phosphates, the cross bridges formation takes place between the globular head and actin. Now like this cross bridges. That's why cross bridges formation compulsory, we need a 1 ATP. When this cross bridges formation takes place here, now here cross bridge formation. Here also another globular head is there. Here also cross bridges. When it is cross bridges takes place, it can pull like this. It is also pull like this. When it is pull like this, what will happen? I already said, suppose I band is bisected by which line? Z line. When it is pull like this, what will happen? Between two successive Z lines, that is called as what? Sarcomere. I already said sarcomere. Now when it is pull like this, what will happen? Sarcomere length is decreases. That's why the first point, at the time of process of muscle contraction, the sarcomere length is decreases. And also can I say I band is towards to A band. And also see, in between A band, I already said they having a zone. That zone is called as what? Z zone. Now when it's pull like this, what will happen? Z zone is also reduced. That's why the first point is what? Sarcomere length is decreases. I band is towards A band. And H zone is reduced or H zone is absent. That is the main changes takes place in at the time of muscle contraction. Now contracted. Later another ATP is releases. That ATP is hydrolyzed and converted to ADP plus pi. This ATP is utilized for the breakdown of these cross bridges. When the cross bridges is breakdown, it will come to their original position. That's why 1 ATP for contraction, 1 ATP for relaxation. 1 ATP is used for the formation of the cross bridges. Another ATP is used for the breakdown of the cross bridges. That is the procedure mainly seen in the process of muscle contraction. That's why in the process of muscle contraction, compulsory involved central nervous system, compulsory involved motor neurons, and also acetylcholine, that is the neurotransmitter, and also with calcium, troponin C, troponin I, troponin T. Now, based upon this, the contractile protein is what? Actin and myosin. This is for the contraction. And for relaxation, that is called as a regulatory one. Who can regulate it? One is the troponin, another one is the tropomyosin. These two proteins is called as a regulatory proteins. Actin and myosin is called as a contractile proteins. This is according to the process of muscle contraction. Thank you.